happy to be here. I want to just briefly start out by introducing myself and also the company I work for. My name is David Bess, and I lead solutions for Neudesic's worldwide power and utilities industry vertical. Neudesic is a consulting agency, and our mission is to help our clients be on the winning side of digital transformation and other disruptions that are taking place in the utility industry. So, all that my business unit does all day long is utilities, and we have solution offerings and specialized experience in areas like grid management, asset management, connected workforce mobility, customer engagement, customer systems, as well as billing and revenue protection. And with that, I want to start off by talking a little bit more about the opportunity in the space of customer communication. So research has shown that 82% of customers prefer proactive communication during an outage. Additionally, customers are more responsive to outage communications than other types of energy utility messages. So I want to unpack that a little bit and kind of do some voiceover and get into some detail here. So what do we actually mean by proactive communication? Because that can mean different things to different people, and there's also the complexity of different communication channels, and customers may have their own preferences, right? And we ideally want to have a system where we respect and honor their preferences for their communication channel. And we also want to have consistency between channels, right? So communication could be a text message that's proactively sent to a customer. If they've chosen to enroll in getting those messages, it could be them logging into a mobile app or into their web portal. It could be even they check the outage map. You have an outage map on your website and they go there and look. And the key to this too, so when we say proactive too, it's, research has shown that customers are much more satisfied and also much more patient when they kind of feel like they know what's going on. They're kept in the loop, and they know that you know that something's going on, right? You're aware of the situation, and it's being addressed. So we'll talk a little bit more about that and some scenarios and what that really looks like later in the presentation. The other key to this statement is around customers are more responsive to outage communication. So we all think about utilities all day long. It's our passion. It's what we do. But the fact of the matter is a lot of customers rarely think about their utility. As long as power is working for them, they're getting what they need. They have good reliability, and they probably have their bill set up on some kind of auto pay, and maybe they've gone paperless, and they might monitor that from time to time to make sure that their bill is within an expected range. And besides that, they never really give a second thought to their utility until something goes wrong, right? So the key point here is when an outage happens, it's a critical moment of truth for the utility as well as for the customers, right? This is now they're hyper-focused on you as a utility, what you're doing, how you're communicating, how you're responding. So that's why it's really important to invest in this area, right? Because for a lot of customers, this is, one of the main ways they're going to engage with you and ultimately judge you. And it goes back into like JD Power, customer satisfaction surveys, all of that. So the point of view I'm sharing, the business case is that this really is an area that's worth investing in heavily because it has a huge impact to customer sentiment. At the same time, only 24% of utility executives feel very well prepared to manage challenges related to extreme weather. So we've seen a lot of extreme weather events. There's parts of the US where they happen routinely, right? We know we're going to get major winter storms or major wind storms, pretty much at least several a year. They are becoming more severe. They're becoming more common. We know that. And so it's a big challenge. And at the same time, there's issues with aging infrastructure and infrastructure that needs to be modernized, as well as, energy transition and digital grid and all these different disruptions that are taking place in the industry that can make this even more challenging. So that was kind of just the summary of the opportunity and why this is important. And the other point here is that accurate customer messaging is more important, more impactful than just mass generic messaging, right? So just to talk through a couple scenarios, if I could send a mass text message that says, we're aware of outages in your area and we're working diligently to address the situation. Not a horrible message, but not at all as good as a text message that says something like, we're aware that you have lost power at, this specific premise. And keep in mind, some customers might have multiple accounts, multiple properties that they manage. They might have multiple residential accounts. They might have residential as well as a commercial account. So one, I guess, tip I would offer is be sure to let them know which account you're referring to, which premise you're referring to, if you have that information. So personalized is better, but it also needs to be accurate. So we don't want to, this is the balancing act. We don't want to send a personalized message, but we weren't completely confident and it ends up being the wrong message, right? We don't want to ever send a customer a notification their power's out when in fact it's not out, or it's been restored when in fact it hasn't been restored. So what we've done there is we've taken an opportunity to delight our customer, and we've actually created a negative situation, in many cases more so than if we had just said nothing at all, because now it's bringing all types of doubt and skepticism into the process. So next, I want to talk a little bit more about the challenge. So some of you watching this presentation, you're very familiar with this problem space, but some of you, this might not be your main focus at your utility. So I am going to go ahead and just talk through this in some detail so that as a group, we have a shared understanding of all the complexities and all the challenges that we're really talking about. So gaining a complete picture of outage status and estimated time to restoration, it requires complex analysis across multiple business processes and technologies, right? So to an outsider maybe, they don't understand, right? They think, I have a smart meter at my house, my utility should know. Either I have power or I don't have power, that meter should know that, and then the utility should know that. Well, yes, in an ideal setting, that would be true, but there's all these other complexities and scenarios that layer in, right? So on the AMI side, I might be doing 15-minute reads, I might even be doing 5-minute reads, but we might have a process set up where those reads are being cached on the device and we're only pulling them in through the head-end system a few times a day. So if I rely solely on AMI, I might have a 6-hour or longer lag to actually know your status. And then once I pull that in, it quickly becomes stale again as I wait, for the refresh of that data. I also might have, and this is very common in an extreme weather event or some type of event that's causing outages, I might have meters that are not communicating, right? So the network itself, the mesh network, if you're in an urban area, it's common to have a mesh network, but there's still some type of node, right, that consolidates that and sends that information further upstream, eventually to your head-end system. And the network itself can be damaged, it can go offline, in which case the meters are just not communicating. So in that case, we're kind of flying blind, at least from the AMI perspective, so we don't have that information. There's other operational technologies that are becoming more common, remote monitoring systems, smart fault indicators, different hazard detection systems, and those are kind of other IoT data sources that can provide information, but again, it can be complex, right? And unless you know how to properly analyze and process that information, it can actually cause more confusion, delays, inefficiencies than it's actually benefiting. So still the best way and the way that utilities figure out what's really going on is they do a damage assessment, right? So I might get some initial indication based on some sensors that I do have that I'm pulling in through my ADMS system or other systems, and that I have a serious issue somewhere. And then I'm going to send a damage assessment team. Now, at that point, I might have some evidence that it's a circuit level outage, and so immediately a decision can be made. Should I communicate to all customers on this circuit that we're aware of an outage in their area. Maybe, maybe not. It really depends, right? It depends on how much of that, like how complete is that AMI data and other sensor data? How timely, like up to date is it? How accurate and confident do I feel in that data? It might be better in many cases to wait till the damage assessment, the initial damage assessment is done. Now, the damage assessment team, there's complexities there too. They need access in the field, ideally to the same operational technology, right? So that they can have situational awareness. So they need access to the network connectivity model, the engineering diagrams of how the circuit's laid out. And, you know, traditionally a lot of things were printed, right? You get things printed out, you take them with you, but it's more efficient and faster, and especially as more and more parts of the grid become digital, we really want a workforce mobility solution, right? Where on-demand crews can pull that information up in a ruggedized type of notebook or tablet, something like that, and get what they need as they move from one job to another. So they do a damage assessment, and they probably enter some information back into the system somehow, right? Would be a typical scenario, which might be a outage management system or an ADMS system. So now I have additional information, and now would be another gate or another time where I could think about pushing a notification to my customers or updating my systems, so that I'm communicating, hey, like we're aware of your outage. And also, by the time you have a good damage assessment done, you might, not always, but you might have enough information to feel that you can provide a good estimated time to restoration. So if that's the case, you do want to communicate that. But again, you also have to balance that with not, you know, communicating inaccurate information, which can cause more harm than good. There's also what we call trouble behind trouble, right? So what I mean by that is I might identify there's a circuit level outage or even maybe a substation level outage in a really bad scenario. And after the damage assessment, I have some sense of what it's going to take to restore, right? And I might do a restore before repair. So that can help restoration go faster, but I might not have a complete picture of, once I address that circuit and that circuit restoration, is there any remaining trouble behind that? So, further down the grid, you know, there might be individual premises that are still out because there's a problem with their individual line drop. And I'm not best equipped to see that until I restore the frontline trouble, the higher level trouble. And then I can start to do an assessment of the trouble behind trouble. So we don't want to, it can be tempting to tell people like, oh, you're going to be restored in 2 hours or 6 hours, whatever it might be, because I know from my damage assessment, that's how long it's going to take to restore this circuit level outage. But we also have to keep in mind, there might be remaining trouble behind trouble. So it can be risky to send that communication to customers because that might apply to 90% of the customers, but 10% of them may still have that lingering outage. And now we've grossly misestimated their time to restoration. There's also the complexities of, like, when you actually start to do the work and you actually want to create the estimated time to restoration, you know, there's different crews with different skills and different seniorities that are able to do different types of jobs, which also require different equipment. And they can also require coordinating with vendors. Maybe I need a third-party vendor to deliver a pole or help me set up a cone hive and direct traffic type of scenarios. So, I mean, there's a whole level of complexity there, and that all has to be considered in the estimated time to restoration as well. And then there's obviously a prioritization that takes place based on, you know, public safety. So police and fire, hospitals, nursing homes, they're going to get usually priority to get restored first. If there's any type of hazard, right, which is like a downed wire, right, or other type of something's electrified that's not supposed to be, that has to be prioritized first. And we need to ideally take that into consideration as well when we're creating our estimated times to restoration, right? I can't just say, oh, this is job type X, so it should be restored in 2 hours. Well, if I have a bunch of hazards that need to be addressed first, then if I can take that into consideration, I can know that your estimated time to restoration is going to be, you know, even a little bit longer because those issues have to be addressed first. So, I mean, there's a lot to this, as many of you know, or some of you are coming to understand. So I just wanted to kind of walk through and level set a bit in detail on the challenge in this space. So what's our strategy? How do we address this? We have created Neudesic a reference pattern, if you will, on an approach on how to address this. So I'll just walk through this a little bit methodically and then also kind of voice over some key points here. So I'll start on the left. We have our source systems, right? So you have your head-end system. You might have your MDMS system as well, which is having your AMI data. You have your customer systems, whatever CRM, billing and payment system. Somehow you have all your customer information on their premise info, stuff like that. You have your asset management system, which is important, for damage assessment, assigning work, figuring out. It comes into play, especially on the estimated time to restoration side. You have your work management system, which has a lot of good information, especially if maybe the damage assessment team enters information back into a system. That would typically be the work management system. So if we're setting up some analytic to help drive accurate customer communication and accurate estimated time to restoration, we're probably going to be pulling some of that info from the work management system as well. We have our various remote monitoring systems, Pi and SCADA systems, which varies widely across utilities, but they may be there, they may not be there. We have our GIS systems, which show, how circuits are laid out, how everything's engineered. Your network connectivity model is going to be tied into that. And then we obviously have our workforce mobility systems as well, which, depending on, your utility and how it's set up, they might be entering notes or different parameters directly into some type of mobility app in the field, and we might connect directly into that, or it might flow first to the work management system, and then we connect from there and get that data we need. So then moving to the right, we recommend having a single unified data layer. So this is getting into, again, the consistency, right? So I've worked with a lot of clients, and it's like, hey, we have a lot of disparate systems and we have a lot of point-to-point integrations. And, this is why you get scenarios where like my outage map on my website doesn't match my communications that I'm sending push text messages. And that doesn't match what an agent sees in CRM if a customer calls in. So those are all bad, negative customer experiences. So the way to, make that better basically the way to make that better is to unify the data in a single data store with a unified data model, so that there's consistency there. Everything's integrated in a single layer. Then moving to the right from that, we do recommend a single unified processing layer, right? So again, ensuring that business logic and analytics are applied consistently, right? And applied once and applied consistently, so that downstream, however that's impacting communications or estimations, there's consistency there. So we have this layer, and I'll talk a little bit more about it actually in a subsequent slide, but it handles complex event processing, and we can also apply some, analytics, some AI and machine learning models there as well. Moving to the right from that, we have a single unified serving layer, right? So we have consistent data, we have consistent processing, but we also need to be consistent. Then ultimately the final step is, how do we serve that information back out to other systems and other channels, right? So it's an important detail not to lose that final step and that final importance of consistency. So basically what we recommend is having a single interface, and then the other systems that are connecting back to it, which might be, again, the CRM system, the work management system, what have you, they all have to interact with that layer in a consistent way. And then on the far right, you have your customer communication channel. So again, if we're wanting to delight customers, we want to communicate and engage with them in their preferred way, right? And different customers, based on, their demographic or their background, they might have different preferences on how we engage with them. So push text messages, SMS, is is a big one, right? It's becoming more and more popular. It's probably the most popular channel today, although some people don't like it. They find it invasive or annoying. So there's also, people have their own web portal, right? Usually that you can log into, and within that experience to be able to check, my status, my estimated time to restoration, so on and so forth. Mobile, a lot of utilities, we have a customer facing mobile app, which is similar, hopefully in a lot of ways consistent with the web portal experience. So again, we want some consistent messaging there as well. And then, many utilities, they have a public outage map on their website as well. So these are all channels that we would say can be fed from this single consistent layer as well. So now I want to double click a little bit more on the analytics, right? So what does this really look like? And this is a huge topic. It takes a ton of work. So I guess my general high level guidance is, if you're going to take on an initiative like this, plan to spend a lot of time getting this piece right. And some of it can be data driven, but some of it also, it's important to have that subject matter expertise as well to advise the business rules and the various processing that should be taking place. So we kind of broke this up into 3 areas. There's pre-processing, right, which is business rules. And again, you can do historical data analysis to try and find evidence for what would make a good business rule, but then also, your various subject matter experts can also help inform this area as well. So, that would be different parameters from the damage assessment that are coming through, and various stuff like that. And then, so basically the pre-processing is to an initial gate, just, is there really even an outage? So it's basically an entry point to this whole process, so that we're not having to process everything all the time, but we can do some intelligent filtering up front. Then, there's an analytics layer, right? So we recommend a scoring model approach, and I'll talk through a little bit about what that means and why that's the case. So if we think about the target variable, like, what is it we want to know? We really want to know, does a customer or a premise have power or not? Or really, there is a third scenario, which is just, we don't know, right? So maybe I cannot determine with a high degree of confidence your power status. So that's going to affect decisions as well. Why use a scoring model? A scoring model is not the most accurate of models per se. Like, there's more modern techniques, XGBoost, things like this. But some of these other approaches, they're more of a black box, right? So you feed in your data, you get out your prediction, and you have to work with that. The nice thing about a scoring model is it's very flexible, and it's also very easy to understand, right? And help draw insights or even tweak the model directly. So what do I mean by a scoring model? So the example we're all familiar with would be probably a credit score, right? So we know at a high level, like, we all have a credit score, and we know there's various factors that impact that. Now, the general public, we don't know the exact factors, right? So in this case, we're building a scoring model, and you're going to get a score. So it's directionally accurate, right? Like, higher scores mean you're more likely to have power. Lower scores mean you're more likely to not have power. But then we also can see all the factors and the weights that are going into that. And so one way that we implement these models, so we do a generalized linear model, we have a binomial response family. And then what we're going to do, we're going to just disregard the intercept, and we're going to take the betas of each of those factors. And, as the practitioner, the analytics practitioner is listening to this, there's a lot that goes into how you pick your variables and tweak all of that. But it's a little bit beyond the scope of this presentation. But let's say that you have a GLM with a certain set of factors that is performing well. You take those, you disregard the intercept, you take the betas, and you renormalize them, right? So they add to 1 if you were to add all the betas together. And then those are basically your factors, your your multipliers. So you take each of the inputs, so you're going to get a score because we've gone through that normalization process and you've disregarded the intercept. You're going to get a score versus an actual like probability prediction, is the way it works. And then there's post-processing business rules, right? So is the meters, so there's things we want to check to really make sure that we're providing accurate information back to our customers, right? So this could be the job status, job detail that comes from the work management system. Is the AMI meter communicating? AMI readings, events and alarms, right? It might be very straightforward, right? It might be the meter's communicating. I have very timely data from the meter and it's showing that that premise has power. So in that case, I don't necessarily even need to go through all these other advanced business rules and scenarios and analytics. I can just straight away say, I'm very confident that this person has power. What is the result? So we kind of talked about this a little bit at the beginning with the opportunity and also during the challenge, but just to restate, why we're doing this and what type of results we can see. So obviously we want to improve customer satisfaction, and research has shown, and we've talked about it, being proactive with communication and providing accurate and personalized information and letting the customer know that you're on top of it, and even updating them as the various stages, like we've assessed the damage, we're conducting repairs, you've been restored, right? More like a pizza maker app type of approach. That greatly improves customer satisfaction. And we also know that this is the time when customers are hyper-focused on you as a utility and how you're performing. So they're going to judge you based a lot of times solely on how you perform during these types of events. There's so that's the main point of all of this, but there are secondary, tertiary effects, that I think are very much worth mentioning that we found with customers when we've conducted this type of analysis and we've implemented this type of initiative. They get more insights into their operations, right? This whole process of getting the data together, doing the analytics, talking about the business rules and the scenarios, it forces conversations and uncovers opportunities on how to improve operations. So kind of a secondary opportunity or effect. Same thing with reliability, right? So obviously, if I'm improving my operations and the way that I'm restoring power faster, then my reliability scores are going to be better than they otherwise would have been. And then obviously, safety is a key piece of this. It's not something the general public necessarily thinks about, top of mind if they're at home and their power's out, but we know that this is extremely important, right? Like if there's a wire down or something's electrified that's not supposed to be, we're talking about life and death type of situation. So doing this type of getting tighter on, because the customer, I guess what I'm trying to say is that when you go through this process of getting really accurate with your customer communications, it means that you really need to understand and have visibility in real time into your own operations, which a lot of utilities, we can't say that we have that dialed in necessarily 100%. It's a scale, it's a spectrum, right, today. So doing an initiative like this moves the needle on that across the board. So it's going to be improving safety, reliability, operations, all of these things, as well as customer communication and customer satisfaction.